In this video, we're talking about 100 different types of engineering fields, every one on the planet. I challenge you to find another, and we're starting right now. Hey 1% Nation, I'm Jake Voorhees, and welcome back to the 1% Engineer Show, where we empower young engineers to rise to the top 1% of their career. So if that is you, make sure you hit the bell and subscribe. There's a lot of great free stuff in the comments below. The 1% Engineer Kit, access to the Discord server, and finally the new IG page, the 1% Engineer Instagram, ran by Rose. Thank you so much for that. This video has a funny story behind it. There is an existing video called 21 Types of Engineers by the Explorers channel, one that I used to help produce videos. I helped narrate several. And the vision behind this video was to create another 2.0 or lookalike video to that one, because that video has no audio, it's not narrated, it's really painful to watch, and it has about 1 million views. So I started to remake that. Then it crept up to 40, 50 different types of engineers, and I kept going, and then all of a sudden it was in the 80s, and I said, what would happen if I actually tried to include every type of engineering that I could find? And I ended it at around 100. There may be a few more out there, super duper narrow niches in engineering, and if I miss something, make sure you comment below. What type of engineer do you want to be? If it's in this video, make sure you add that in the comments. Really quickly about the structure of this, there are 4 primary categories of engineering: mechanical, civil, software, and electrical. Computer engineering is under electrical engineering. Those are the big 4. And then finally, there is an interdisciplinary concept around engineering. For example, mechatronics doesn't really fit into mechanical, doesn't really fit into electrical. It's both. So this video has an entire structure around it. I will start with mechanical engineering and then every type of engineering within mechanical before moving on to then software and then civil. So make sure you watch this entire video, guys, and let's get started without further ado with engineering type number 1, mechanical engineering. Mechanical engineering is a discipline that combines engineering physics and math principles with material science to design, analyze, manufacture, and maintain mechanical systems. It's the broadest type of engineering. There's about 350,000 mechanical engineers employed in America alone, and it's more than any other, so we're starting with that. Within mechanical, we have a whole family tree of other types of engineering, so let's get right into that. Acoustical engineering, which deals with sound and vibration. It includes the application of acoustics and the science of sound within technology. Aerospace engineering, which is concerned with the development of aircraft and spacecraft. It has 2 major overlapping branches. The first one being aeronautical engineering. Aeronautical engineering is aerospace engineering that deals with things within our atmosphere, so planes and things that are not outside of orbit. And then the secondary part of aerospace is astronautical engineering. Astronautical engineering deals with satellites and things outside of orbit, actually in outer space. Automotive engineering. Automotive engineers design, manufacture, and deal with the operations of motorcycles, automobiles, and trucks and their respective engineering subsystems. It also deals with the modification of vehicles. This is most likely the most popular avenue within mechanical engineering. I get so many questions about automotive engineering. Biomedical engineering. There's only about 19,000 biomedical engineers employed in America. It's a very niche field, one of the fewest. We do have a video on that. Go check that out. They deal with the design and concepts around medicine and biology to amplify healthcare purposes. This field closes the gap between engineering and medicine, combining the design and problem-solving skills of engineers with biological sciences. Manufacturing engineering. This requires the ability to plan the practices of manufacturing, research and development tools, processes, machines, equipment, everything that is going on with manufacturing engineering. That's what these types of engineers do. Production engineering. A production engineer typically has a wide knowledge of engineering practices and is aware of the management challenges related to production. The goal is to accomplish the production processes in the smoothest, most judicious, and economical way. Optomechanical engineering. Most of you will never have heard of this. They design and develop optomechanical systems, devices, and components such as optical mirrors and optical mounts. Look into this. It's very niche, but an interesting field. Thermal engineering, which is a specialized subdiscipline which involves mechanical and chemical engineering together. Deals with the movement of heat energy and transfer. The energy can be transformed between 2 mediums or transformed into other types of energy. Sports engineering. I've had a lot of friends who want to design helmets and do things within sports that they think is cool because they were an athlete. This field would be for you. This can be thought of as the application of math and physics to solve sports problems. They might include designing equipment, building facilities, analyzing athletic performance, regulating standards, and ensuring that safety requirements are met for these athletes. Vehicle engineering, which is the parent of automotive and aerospace engineering. They integrate the engineering and business acumen to ensure that vehicles are designed, developed, and produced within cost requirements. This field uses many scientific principles, including thermodynamics, to enhance the operation and develop solutions to design flaws. Power plant engineering. This is defined as the engineering and technology required for the production of central station electric power. The field is focused on the generation of power for industries and communities, not for household production. All right, those are the fields within mechanical engineering. I'm a little torn here because myself as a civil engineer, I want to put that first, but software engineering is so broad and so popular, we're going to put that next because there's about 1.3 million people who are hired as software developers in America alone, not necessarily engineers. So let's get started with the family tree of software engineering. Software engineers develop software. They build, they make, they construct software. It's a branch of computer science. Actually, today, by the time this is out, the video will already be there. What do software engineers do? Episode 107 is out now. So within software engineering, let's open that up. You could be a front-end engineer. Front-end engineers implement the visual elements that users see and interact with within the web application. They design, select, and install the user interface of that application. Next, you have backend engineers. They work on the server components of multi-tier web applications. They focus on web services and the data storage, modeling, and databases. They also may be involved with the business and implementation of the logic. Next up, you have a full stack engineer. As you can imagine, this is both front end and back end. They can tackle projects that involve databases, user-facing websites, work on clients within problem solving, and do the full range of software engineering needs. You could be a DevOps engineer. This is an IT professional who works with software developers, systems operators, and other staff to oversee code and release the deployments. The role calls for someone who has relevant hard and soft skills to overcome the traditional barriers between software development, quality assurance, testing, and IT operations teams. So if I was going to work within software engineering, this would probably be me. I'm not going to be the best coder. I'm not going to be the best technical person. I have really good communication, team management skills. So this is a really interesting field for me personally. Maybe it is for you too. Comment below. System software engineering. They design computer software systems that streamline internal operations, such as the communications, inventory, and record keeping in industries ranging from finance to medical research. You could be a security software engineer. This is a specialized type of engineering that focuses on the security aspects in the design of systems that need to be able to deal robustly with possible sources of disruption, ranging from natural disasters to malicious acts. You could be a quality assurance engineer. This is someone who monitors every phase of the software development process, making sure that the software adheres to the standards set by the development company. You could be a web development engineer. They work in the development of a website for the internet, if you've ever heard of it. It's a great technology. Check it out. And maybe that's how you got here today. It could range anywhere from developing simple single static pages with plain text to complex web-based internet applications, electronic businesses, social networking services, and beyond. Embedded systems engineer. They deal with the process of controlling various devices and machines that are different from traditional computers. They integrate software engineering with non-computer devices and leads to the formation of embedded systems. You could be an information engineer. This is the discipline that deals with the generation, distribution, analysis, and use of information, data, and knowledge in systems. Okay, with everything in software engineering covered now, let's move on to civil. There are 5 subsets of civil engineering, but in general, civil engineering is the discipline that deals with the design, construction, and maintenance of the physical and naturally built environment, including public works such as roads, bridges, canals, dams, airports, sewage systems, pipelines, structural components, basically anything that is designed and in terms of infrastructure or things that influence civilian and human life that could also be the environment. It doesn't have to do with exclusively infrastructure, but this is civil engineering. Civil engineers, for the most part, build bridges and roads. That's what they do. Okay, within civil engineering, you have coastal engineering. They focus on the specific demands posed by constructing at or near the coast, such as the development of the coast itself. So jetties and barriers and dealing with scours and dealing with bridge piles. This is what coastal engineers do. You have structural engineers. They create the drawings and specifications, perform calculations, and review the work of other engineers, write reports, evaluations, and observe construction sites. If you want to build and design those buildings and bridges, this is the type of engineering for you. Within structural, you have 2 types. You can be an architectural engineer. They deal with the technological aspects and multidisciplinary approach to planning, design, construction, and the operation of buildings. One of my most popular videos is engineers versus architects, and I have one on architectural geotechnical engineering, go check that out, guys. You could be a construction engineer. This deals with the designing, planning, and construction and management of infrastructure such as roads, tunnels, bridges, airports, all the things that actually get designed and implemented by civil engineers. Construction engineers are there to make sure that it all goes smoothly. A lot of people ask me, what if I want to be on site more? What if I want to actually be there to see things happen within civil engineering? This is the way to achieve that. All right, moving on. Another primary field of civil engineering is geotechnical engineering, which is everything under the ground. This is the application of scientific method and engineering principles to the acquisition, interpretation, and use of knowledge of materials of the Earth's crust and earth materials for the solution of engineering problems and the design of engineering works. So foundations, retaining walls, all these pipes and utilities that are underground, this is what geotech engineers do. You could be a geomatics engineer. This is the management of global infrastructure through the collection, measuring, monitoring, and achieving of geospatial data. Also within geotech, you could be a geological engineer. This is application of geology to engineering study for the purpose of assuring that the geological factors regarding the location, design, construction, and operation of engineering works are recognized and accounted for. And then finally, you have mining engineering. This deals with the extraction of minerals from underneath the ground, above the ground, or within it. Technically, a lot of people consider petroleum engineering within geotechnical engineering, but I did not include that, so you'll hear about that later. All right, subgroup within civil number 4 is transportation engineer. This is the field that I went into. This is application of technology and scientific principles to the planning, functional design, operation, and management of facilities or any mode of transportation in order to provide for the safe, efficient, rapid, comfortable, convenient, economical, and environmentally capable movement of people and goods and transport. Within transportation engineering, you have things like freight, safety, traffic, airways, seaways, road construction, what the roads are actually made with. It's a really broad field, so let's dive into that. Within transportation, you could be a railway engineer. This is a multifaceted engineering discipline dealing with the design, construction, and operation of all types of rail systems. You could be a traffic engineer. This is what I did. This uses engineering techniques to achieve the safe and efficient movement of people and goods on roadways. Traffic engineers could even deal with things like livestock, how they move around in an industrial agribusiness situation. It's even more broad than that. Within traffic engineering, I even worked with this thing called intelligent transportation systems, which is things like connected vehicles, data and monitoring systems, and everything that's actually linked in with tech and civil engineering. That's why I chose that field. You could be a highway engineer. This involves the planning, design, construction, operation, and maintenance of roads, bridges, and tunnels to ensure the safe and effective transportation of people and goods. Highway engineering design is very boring. I was never into it. The classes stunk and it was just the worst, so I avoided that. If you like it, more power to you. And finally, probably the most boring type of engineering I've ever met on the planet is pavement engineer. There's actually people that literally just create different types of concretes and different types of asphalt so that our roads last longer and are safer and don't get destroyed by big trucks, but it is so boring. It's basically just taking all these samples of different types of concrete and pavement and testing them over and over and over again in a lab. It sucks. But they design and maintain the flexible types of roads, asphalt, and the rigid ones, which is concrete. Oh, right, the final bracket of civil engineering is environmental engineering. They take the broad scientific topics like chemistry, biology, ecology, geology, hydraulics, hydrology, microbiology, and math to create solutions that will protect and also improve the health of living organisms and improve the quality of the environment in general. Within that, you have several types. You could be a marine engineer. This involves the boats, ships, oil rigs, and other types of marine vessels or structures, as well as oceanographic engineering or ocean engineering. You could be a sustainability engineer. This is typically offered at the master's level. It's pretty niche. This is the process of designing or operating systems such that they use energy and resources sustainably, so they don't compromise the environment. This is a big deal, guys. You want to be able to reuse as much as possible before you even recycle and be 100% sustainable. We are not as a human species. We waste a lot of things. You could be a water resources engineer. This is technically also known as the field of hydrology, but I had a course in university called water resources engineering, so it made this list. This is the design of new systems and equipment that help manage human water resources. This includes water treatment facilities, underground wells, and natural springs. And finally, you could be a sanitation engineer. This is application of engineering methods to improve sanitation of human communities, primarily by providing the removal and disposal of human waste in addition to the supply of safe, drinkable, or potable water. All right, guys, we made it to the fourth main core field of engineering, which is electrical engineering. If you're waiting for chemical, wait till the end. There's only 34,000 chemical engineers employed deployed in America. It's not technically interdisciplinary, but it kind of stands alone. So let's get started with electrical engineering right now. This is a discipline concerned with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. A lot of you guys are going to be pissed about this, but computer engineering is technically a type of electrical engineering. I had a buddy who only took like 2 extra classes, and he got a double major in electrical and computer engineering because they're basically the same thing. Computer engineers integrate several fields of computer science and electronic engineering, which is required to develop computer hardware and software. They usually have training in electrical or electronic engineering, software design, hardware/software integration, instead of only software engineering or instead of only electronic engineering. You could be a control engineer. They apply control theory to design systems with desired behaviors in control environments. There's a heavy overlap of mechanical and electrical engineering here, so it could be under interdisciplinary, but it's here in electrical. Okay, there's a couple different types of computer engineering. You could be a computer hardware engineer. They design, develop, test, and produce computer systems and the various physical components related to those systems. Technology has made this field expand to include hardware devices, which enable embedded software engineering in non-computer devices. You could be a computer engineer who works within software engineering. These types of computer engineers end up more in a software engineering or software development type of role. Yes, they're a computer engineer and they deal with those hardware systems, but they're mostly working on the software end of things. You could be a computer networking engineer. Network engineers construct and manage the networks to ensure they're optimized and functioning as intended. They're responsible for the foundation of an organization's IT system, so their responsibility is really high. All right, within electrical engineering, you could be an electronics engineer. This utilizes the nonlinear and active electronical components to design electronic circuits, VLSI devices, and other systems. The discipline typically also designs passive electrical components, usually based on printed circuit boards. Within electronics, there's a few types. You can be a microelectronic engineer. This deals with the microfabrication of very small electronic designs and components. These include transistors, capacitors, inductors, resistors, diodes, and things that can be found in microelectronic devices. You could be a nano-electronic engineer. This deals with nanotechnology, which covers a diverse set of devices and materials, which are so small that interatomic interactions and quantum mechanic properties need to be studied extensively. If you guys hear a lot about quantum computing, quantum mechanics, nano-electronic engineering is where you want to go. You could be a microwave engineer. This is the study and design of microwave circuits, components, and systems. Fundamental principles are applied to analysis, design, and measurement techniques in this field. The short wavelengths involved with microwave engineering distinguishes the discipline from electronic engineering. Next up being signal processing engineering. This is a subfield that focuses on the analysis, modification, and synthesis of signals, such as sound, images, and scientific measurements. You could be a telecommunications engineer. This deals with the exchange of information across channels via wired or wireless means. This bridges the elements of electronical engineering, including computer engineering and systems engineering, to create and improve telecommunication systems. You could be an RF engineer, radio frequency engineer. This deals with the application of transmission line, waveguide, and antenna and electromagnetic field principles to design and apply things to devices that produce or utilize signals within the radio band. You might not ever have listened to the radio if you're a young engineer today, but even things like how we communicate with our planes, how we communicate with our satellites, all of this is radio frequency, guys. Radio waves are very powerful technology. It just only communicates sound. And because of that, television and video and the internet have moved on, but it's still very important. You could be a power engineer. This is a major subset within electrical engineering. It deals with the generation, transmission, distribution, and utilization of electric power and the apparatus connected to such systems. The final type of electrical engineering is optical engineering. This focuses on the application of optics, such as the design of optical instruments like lenses, microscopes, telescopes, and other equipment that utilizes the property of light using physics and chemistry. As you can see, there's a bunch of branches that could have fallen under interdisciplinary, but I used my judgment in placing them. I didn't want to make chemical engineering its own field, but there's so many different subsets within chemical engineering that it sort of has to be. There's only about 34,000 chemical engineers employed in America, which is 10 times less than the amount of civil or the amount of mechanical engineers. There's even 4 times the amount of architects out there in the world than chemical engineers. So it's just a risky type of field. And I don't encourage it. I also don't think it's going to grow too heavily in the future because we're more interested in sustainable things and nanotechnology and not using chemicals that are bad for the environment, bad for our bodies. But either way, we have to talk about it. It's the production and manufacturing of products through chemical processes. This includes designing equipment, systems, and processes for refining raw materials and for mixing, compounding, and processing chemicals to make valuable products. Typically, chemical engineers work within the petrochemical industry because all plastics, paints, so much of the stuff all around you right now comes from oil. So chemical engineering is heavily entrenched in the oil sector. Another reason why I don't like it. Moving on. There's a whole bunch of little types of chemical engineering, so let's get into those. Starting with biomolecular engineering. They deal with biological molecules. Some things might include the manipulation of acids, lipids, carbohydrates, and proteins for many applications, including groundbreaking techniques to understand malaria or even coronavirus, and novel technologies to probe the brain and its function. We could be a materials engineer. I don't really like this one being under chemical. Maybe it should be under interdisciplinary, doesn't matter. This is the field of materials science, deals with the design and discovery of new materials, particularly solids. Within that, let's talk about two subfields of material engineering. You could be a ceramics engineer. This is the science and technology of creating objects from inorganic, non-metallic materials. That's what ceramics are. You could also be a plastics engineer. This encompasses the processing, design, development, and manufacturing of plastic products. Plastic is a petrochemical. I also don't like it. It's from oil. It's not sustainable. Plastics are bad for the environment. They don't break down. Look at the South Pacific trash pile. It is ridiculous. Plastic is bad. Don't become a plastics engineer, guys. You could be a molecular engineer. They deal with the design and testing of molecular properties, behavior, and interactions in order to assemble better materials, systems, and processes for specific functions. Some chemical engineers become process engineers. This deals with applications of the fundamental principles and laws of nature and allows us to transform raw materials and energy into products that are useful to society at an industry level. Corrosion engineering. They apply scientific, technical, and engineering skills and knowledge of natural laws and physical resources to design and implement materials, structures, devices, systems, and procedures to manage corrosion. This is a big deal. Everybody knows what rust looks like. Preventing corrosion is a huge industry. You could be a biochemical engineer. They design, construct, and advance unit processes that involve biological organisms or organic molecules and has various applications, including biofuels, food, pharmaceuticals, technology, and water treatment processes. You could be an electrochemical engineer. They deal with the technological applications of electrochemical phenomena, such as electrosynthesis of chemicals, refinement of metals, flow batteries, fuel cells, surface modifications, and so on. You could be a pharmaceutical engineer. They discover, formulate, and manufacture medication, as well as analytical and quality control processes for drugs. You could be a reaction engineer. This is a specialty within chemical engineering or industrial chemistry dealing with chemical reactors. That's a controlled environment where you create chemical reactions, just like a nuclear reactor. Controlled environment where you create a nuclear reaction. Then finally, you could be a bioprocess engineer. They design and develop the equipment and processes for the manufacturing of products such as agriculture, food, feed, pharmaceuticals, chemicals, polymers, paper, and beyond. All right, let's get into interdisciplinary fields. Agriculture engineers. There's only about 5,000 of these employed in America, so it's incredibly niche. This deals with the engineering of agricultural production and processing. It combines the disciplines of mechanical, civil, electrical, food science, and chemical engineering with the knowledge of agricultural principles. Industrial engineering. See, this is why chemical can't be one of the big five, because industrial engineering is far bigger. There's over 100,000 of them employed in America, and still industrial engineering is an interdisciplinary type. This is the profession that is concerned with the optimization of complex processes, systems, or organizations by developing, improving, and implementing integrated systems of people, money, knowledge, information, equipment, energy, and materials. There's 285,000 industrial engineers employed in America. Civil has 326. Mechanical and civil are both over 300,000. So this is a huge field that no one is out there talking about. I need to make more videos on industrial engineering. You could be an energy engineer. This is a broad field of engineering dealing with energy efficiency, services, facility management, plant engineering, environmental compliance, sustainable energy, and renewable energy technologies. I do hear a lot of interest and a lot of people who want to become energy engineers today or sustainability engineers today, guys, because they want to save the planet because they know that we have ruined it. You could be a metallurgical engineer, however you're supposed to say that. This is a study of metals. It includes mining, extraction, design, and processing of metals, as well as how metals react to environmental changes or stress. This one's really cool. Earthquake engineering. Interdisciplinary branch of engineering that designs and analyzes structures such as buildings and bridges with earthquakes in mind. The goal is to make structures more resistant to earthquakes. I had a friend who got her PhD in earthquake engineering. She worked with how bridge piles actually settle deeper into the earth instead of crumbling and being dismantled during an earthquake. It's a very interesting field. All right, here we got it, guys. Mechatronics. I get more requests to make a mechatronics video than any other type of engineering, and I still haven't because I don't think it's searched enough to make it. This is the multidisciplinary branch of engineering that focuses on the engineering of both electrical and mechanical systems. That's the mechanical, and tronics. Mechatronics is mechanical and electronics. That's what it means. This includes the combination of robotics, electronics, computer, telecommunications, systems control, and product engineering. Next, you have robotics engineering. I've heard so many people describe mechatronics by saying it's basically robotics engineering. It's not true. Robotics is a portion of mechatronics. The main difference is that a robot doesn't have influence and control from outside. It actually is autonomous. It does whatever it wants. That's the point of a robot. But when you show up to a traffic light, that's also a mechatronic system. But there is no autonomy. It's pre-programmed to do a specific thing when an input is met. That's the difference. Robots acquire their inputs, they gather them, they sense them. Computer vision, that's robotics. Mechatronics are given their inputs. You can be a paper engineer. I did not believe this, but then when I did my research, I found 10 different programs in America around paper science or paper engineering. This is the physical science and life sciences in conjunction with mathematics as applied to converting the raw materials into useful paper products and co-products. Even though we don't use paper like we used to, it's not going away anytime soon. So maybe this could be for you, but it's incredibly niche. Never heard of this one either before this project, but you could be a photonics engineer. This is someone who creates and improves systems and products that use photonics, which is lasers, optics, fiber optics, and imaging. You want to be a laser engineer? This is how you do it. You can be a health and safety engineer. They combine the knowledge of engineering and health and safety to develop procedures and design systems to protect people from illness and injury and property damage. Biological engineering. This is the application of engineering principles to analyze biological systems and to solve problems in the interfacing of such systems, plant, animal, or microbial, with human-designed machines, structures, processes, and instrumentation. You could be a building services engineer. For example, a huge amount of mechanical engineers just end up working in the heating and ventilation systems within buildings. That's one of the primary subsets of mechanical engineering, and this is technically under that. They're responsible for the design, installation, operation, and monitoring of technical services in buildings in order to ensure the safe, comfortable, and environmentally friendly operation of that building. You could be an information engineer. This could technically go under software engineering, but I didn't put it there. This deals with the generation, distribution, analysis, and use of information, data, and knowledge in systems. You could go into engineering management. This career brings together technological problem solving of engineering and the organizational, administrative, and planning abilities of management in order to oversee the operational performance of complex engineering-driven enterprises. Within civil engineering, there is a degree for engineering, construction, and management, and so that's an example of how you would use this field for your career. You could be a military engineer. I don't really believe in 5% of the American budget going towards the military. I don't think we should have 1,000 bases all over the world. I don't think we should intervene in other countries like we've done endlessly, so I do not encourage this field either, but it's pretty cool. This is the art, science, and practice of designing and building military works and maintaining the lines of military transport and military communications. The final thing I'll say about the military is if you look at Japan's culture before attacking Pearl Harbor, they said that the emperor basically said that war is the final straw. You should always avoid it. And war makes a ton of money, which is why it's never stopped around the world. So I just don't believe in military engineering in general, but it's a huge industry. Lockheed Martin, Northrop Grumman, companies like this make billions of dollars on war and people and families and communities being destroyed, and I don't want to talk about it anymore. You could go into nano engineering. Don't confuse this with a nanotechnology engineer within electrical engineer. This is the practice of engineering on a nanoscale. It derives its name from the nanometer, but anything dealing with things at that scale is nano engineering. So technically it's more broad than nanotechnology engineering. You could be a nuclear engineering. I also have a weird relationship putting this one in there because nuclear engineering is a decently broad field, and it's not as bad as military engineering or petroleum engineering. We just don't know how to deal with nuclear waste, so it's highly productive and creates a lot of energy, but it's not sustainable at all. So it's a weird one. This deals with breaking down atomic nuclei, which is fission, or of combining atomic nuclei, which is fusion, all around the principles of nuclear physics. I think one day we'll figure out nuclear engineering, but today we have not. So I don't really support this one either. It's a really cool, really productive field, but Unless we can solve the problem of how to deal with the waste, we'll like shoot it into outer space because we can't keep it on this planet, then it's going to be an interesting future. You could be a supply chain engineer. This deals with the planning, design, and operation of supply chains. Some of its main areas include logistics, production, and pricing. Systems engineering. This is an intersection of engineering and engineering management that focuses on how to design, integrate, and manage complex systems over their life cycles. And within that, you have reliability engineering. This emphasizes the ability of equipment to function without failure. Reliability describes the ability of a system or component to function under said conditions for a specified period of time. You could be a textile engineer. This is a pretty big branch, but it combines multiple things, so it's within interdisciplinary. They design and develop the processes, equipment, and procedures that create all fibers, yarns, and fabrics. We wear clothes made of textiles, so we need textile engineers. You could be a food engineer. This is a field which combines microbiology, applied physical sciences, chemistry, and engineering for food and related industries. Unfortunately, food engineering has bridged into genetic engineering. This is also called genetic modification or genetic manipulation, but it's the direct manipulation of an organism's genes using biotechnology. You could be a broadcast engineer. They deal with radio and television broadcasting. Audio engineering and RF engineers are also essential parts of broadcast engineering. And finally, we have audio engineering. They help to produce a recording or live performance, balancing and adjusting sound sources using equalization and audio effects, mixing, reproduction, and reinforcement of sound. There we have it, guys. That's 100 different types of engineering. There might be 101 or something. Please, somebody go check my math here. Thanks again for watching the 1% Engineer Show, guys, where we empower young engineers to rise to the top 1% of their career. So if this is you and you enjoyed this video, make sure you hit the notification bell and subscribe. What type of engineering is your dream job? Which of these excited you the most? Which of these had you never heard of before? Comment below. If you want the 1% Engineer Kit or access to the Discord server, find those links in the description. Thanks again, guys, and we'll see you in another video. Bye-bye.